All right, gang, so today's lecture U, we're going to go and need to open the attachment that's attached to the lecture U Dropbox, just like it was a homework assignment. There's the, you're going to need to go ahead and open it and copy some stuff out of it, so I'm going to want you to go ahead and find this. We're going to copy some stuff rather than just type in 10,000 lines of code. But let's go ahead and look at, let's go ahead and look at the documentation, what we're going to be doing. So just as a reminder, in math we have a plane called the Cartesian coordinate system where you have an x coordinate and a y coordinate, kind of like rows and columns. So, sometimes we say that position 0, 0 is in the middle, and then negative numbers go off one way and positive numbers go off in another. We can say that, this is position number 50, 50, that kind of thing. So we're going to need that because we want to be able to draw our bear. And so what we're going to do is we're going to have a draw circle function where we specify where we want the circle to start, the diameter of it, and the color. And so with the function, that lets us specify its starting point, the diameter of the circle, the radius of the circle, and the color. That's something that's drawn entirely with circles. We already have that code, but we're going to make some modifications first. So, firstly, we're going to talk about the coordinate system and how we might need to scale and shift things. What does scale and shift mean? Well, it's like if you're viewing something and what you're viewing is kind of small and you want to be able to hit the scroll wheel and zoom in on it, that's called scaling, right? Or if it's kind of off to the side and you wish you could push it over to see it in the middle of the screen, that's called shifting. So if we had something that was like this, but we wanted to show up in the middle of the screen, we'd have to shift its coordinates. Or if we had a small shape and then we wanted it blown up to be larger, we would have to scale the coordinates. So here we go. What are the Cartesian coordinates of this yellow point? Well, x is equal to 10, and y is equal to 30. So if you have the Word document open, which I recommend you do, go ahead and do that. X equals 10. Why did I type in 20 when it's actually equal to 30? All right, and so now, what is the xy coordinate and the radius of the origin of the circle? Now, for our particular drawing function, circles don't start drawing in the middle. We've already seen when we use the turtle library and we say draw a circle, it starts from the edge. So we need the xy coordinate and the radius of this. Well,
we're in lecture U, right?
Yes. So this is x40. Has anybody else got it open? Okay, good.
I'm downloading it. So you could.
Yeah. All right, cool. So if all the circles are going to be marked by their rightmost side, we're going to need to take note of those coordinates. So for example, this one is at 40, 20. Not 49. And he has a radius of, radius is halfway to the circle to the edge. It looks like it goes from like 25 to 40. So that's about a radius of 15. Radius is just half of the diameter, and so since this circle goes from 10 to 40, that's a diameter of 30, so the radius is 15. So we're going to tackle the bear, but we're going to do a simplified version of it first. These are the pieces we're going to tackle first. And the order in which we draw them is going to be important. Like if we draw the black circle and then we draw the great big brown circle, it's going to cover up the black circle and we won't see his mouth. So the pieces that are behind everything are the ones that need to be drawn first. So we're going to draw an ear, and then we're going to draw another ear, and then we're going to slap a head down, and it's going to partially obscure the ears. If we did it in the wrong order, then the ears would be in front of the head, which might look okay, but it would not look good if the head was in front of the eyes. So here we go. This is what we want to draw with a graph superimposed. So let's just do 3 pieces of the bear first. Let's do his 2 ears and his head. All right, so ear 1 starts at that position right there. We need to find the x and the y and the radius of it. I'm going to kind of zoom in. It looks like it's at about x, maybe 25. Y is 51. 25, 51 with a radius of about maybe 15 again. I don't know. There's that 10. I'm going to say 10. Yeah. Okay. So x is 24, y is 51, radius is 10. So 24, y is 51 with a radius of 10. Now the other ear ought to just have the same radius, right? I mean, whatever's drawn. I want his ears to match. So I'm going to assume that the other ear has the same radius. It has a different position, though. It ought to be of the same height, so it ought to have the same y coordinate. But its x coordinate of its circle origin looks like it's about 77, 76. Let's go with 76. So x position 76, y position 51, and now the head. Well, the head looks pretty easy to spot. It's got an x position of 70, a y position of 30, and a radius of 10, 20, 30. So 70, whoops, the head starts at x position 70, y position 30, and a radius of 30. And we're going to need to take note of those numbers because we're going to need to modify our code so that when we call a draw circle function, we can say do draw circle 24, 51, radius of 10 with a color of tan. Fortunately, most of that code is already written for us. So we need to copy this code and paste it into a Python script. You need to copy all that stuff that's in that box on page 7. And we'll talk about what it does, of course. So I'm going to say this is lecture U. All right, so the methods, the functions in this. There's a couple of them. There's one called relocate. And all relocate does is it moves the cursor from one spot to another. And then there's another one called crosshairs, which draws a pair of crosshairs somewhere. And then there's a last one called circle, which draws a circle at a specified position. So it's got 2 things down here. One, it's drawing a pair of crosshairs, and then the other, it's drawing a circle. We may as well go ahead and run it and see what it looks like. All right, there's our crosshairs, and it drew a circle there. Now, we don't want a blue circle. That's not part of our bear. We want 3 other circles, though, with the coordinates that we just mapped out on our Word document. So one circle needs to be 24, 51. Let's see if I can get these both on the screen at the same time. All right. So I'm going to delete that circle. I don't want to draw a blue circle. right, so circle parentheses 24 comma 51 comma 10 comma quote 10 end quote into parentheses, just like that.
Where'd you go get your,
The code is on page 7. Now let's add a second circle. Circle 76 comma 51 comma 10 comma quote 10 end quote in parentheses. And then lastly, circle 70 comma 30 comma 30 comma quote 10 end quote in parentheses. All right, there's our bear. He's kind of tiny. Doesn't look nearly as good as the one in the Word document. We need to shift him so that he's in the middle, and we need to scale him so that he's larger. And yeah, we could play with changing our coordinates, but I don't feel like trying to change our data to get him to move into the center of the screen. I feel like changing the program to move him for us. So shifting coordinates. The problem, our bear is tiny, and it's in the wrong place, the upper right quadrant. We want it in the center of the window. So we need to learn about shifting and scaling. When you shift something, it's to move the coordinates, to change the XY coordinates, to add something to X, or to reduce something from X, or to modify Y so that it's in a different place in the screen. So for example, if we have this circle here, this blue circle, but we wanted it to be drawn here, what would we have to do? We'd have to subtract some value from X to move it over to the side, and then we'd have to subtract some value from Y to get it down here. So the original value, the original X value of our circle is 50. The original Y value of our circle is 30. You'll see where I'm getting these numbers, I hope, right? 50, 30. The new circle is at position 10, comma 0, right? X10, Y0. And if you didn't get those circle commands copied into your Python program that we did, page back, don't worry, we'll get back to it. So we've got 10, 0, right? X is 10, Y is 0. And so what's the shift value? Well, in this case, it should have been shifted by minus 40, right? To get from 50 to 10, we needed to subtract 40 from the X value to get it here. And then from the Y value, we needed to shift minus 30, right? Because he was here, and then if we subtracted 30 from his Y value, it would settle him down here. Scaling, on the other hand, is changing something's shape. Say we had this line. And we want it to look great big, like that. So we're going to, just like we were zooming in or out, we need to change the coordinates. We need to modify the coordinates by multiplying or dividing by a value. That's how you shift, right? If you have the size of something and you divide everything by 2, it's going to be smaller. If you have the size of everything and you multiply it by 2, then it's going to be larger. So here's the original line, and there's the line that we wanted to be changed. So, looks like I have a glitch here. I guess we can just do the X value rather than, so here we go. Here's B1's point. B1's X value is 20. So B1's X value is 20. B2's X value is, looks like about 40. And so its scaling factor is 2. 40 divided by 20 is 2. So if we wanted to redraw this guy and get it scaled properly, then we would need to multiply its coordinates by 2, get it to be larger. Now the only reason we can do it that simply is because this intersects 0, 0, but we're just trying to get the ideas across. So if you add values to the coordinates, you're shifting it, right? I'm going to add 10 to its x, okay, it moves over 10. I'm going to add 10 to its y, okay, it moves up. But if you're multiplying the coordinates by values or dividing them, then you're scaling it. I'm going to multiply everything by a factor of 10. Okay, now the image is going to be 10 times as large. So we need to make some changes, and apparently I forgot to put in the code that we were going to do this. There seems to be a page missing. So we're going to figure out what changes we need to make in order to shift our bear into the proper place. And if we look at it, then our bear coordinates are like this, but our turtle graph starts with the middle being at 0, 0, right? So this spot right here really needs to be here, right? Because we want it to run so that he is in the middle. Let's draw our bear again to take a look at how he currently draws. Oh, looks like I had it there, but I can do it again. There, right? So we're just seeing this little coordinate system right up here on our Word document. If we go and compare what we got there with our output, then we'll see that we need to shift our bear over. And so the amount that we're going to shift the bear over, we just want his nose here, his imaginary nose, to be at 0, 0, rather than what it is currently right now, which is 40, 30, right? Because I want his nose to be 0, 0, so I'm going to have to subtract 40 from the x coordinate. And I want this to be the middle of the page at 0, 0, so I'm going to have to subtract 30 from the y. So I'm going to go back to the code, and I'm going to pause it for a moment in case anybody didn't get this part in. All right, so if you were unable to get the source code from the Word document, because you're viewing it with another viewer other than Word, you can go and find it now. Go to your Assignments tab, refresh your Assignments tab, however, go down to U, and we will see lectureu.txt. If you grab that and save it and open it, you will see the Python code, which you will then copy and paste into your own Python program. So while getting that ready, I accidentally lost my circles. So I'm going to put them back there. And then I'm going to make the changes I said about shifting. So I don't want the blue circle, and you've already most likely done this part. Get rid of the blue circle. It gets funner, I promise. Sorry that the files weren't right where we needed them. Okay, so need to draw a circle to represent the ear. Circle 24, 51, 10, quote tan, end quote. Circle 76, 51, 10, quote tan, end quote. And then circle, what's the third one? 70, 30, 30, quote tan. And if you wanted your bear to have different colors other than tan, that'd be okay. One difference I see is that in our illustration here, every border has a thick outline, right? A stroke, as you would call it in Adobe Illustrator. But when we run our programs, we don't see that. Yeah, there they are. Okay. So there it goes, but I want to scale it so that it's over in the middle. And by looking at our drawing, we saw that we needed to move the x coordinates over, I think by, better verify this, we needed to move everything over so that everything needed to be shifted by 40 on the x-axis, and everything needed to be shifted by 30 on the y-axis. So to get that to work, we're going to come up here to the circle function, and before we start relocating and moving and stuff like that, we're going to modify the values that we want. So I think we figured out that we said we want to shift on the x-axis by 30. So shift x is equal to 30. Shift y, I think we said was 40. And if I have those reversed, then we'll flip them in a minute. And now we need to change the values of x and y by those amounts. So we're going to say x minus, tell you what, let's make this shift x equals minus 30 and shift y equals minus 40. And then we're going to say shift plus equals shift x. And y plus equals shift y. Now when I run it, hopefully he'll be dead in the middle of the screen. Not quite. I think I need to reverse the numbers, I think, when I said 40 and 30. So shift x ought to be 40. Shift y ought to be 30. Well, that's looking good, but it's still tiny. But if we multiply our coordinates by a value, we can increase it. So along with our shift functions, we need a scale function. We need a scale factor. So how about scale equals 2, just in case we want to blow everything up by 2. So x times equals scale, and y times equals scale. That's going to be larger. Well, that's not quite right. That's not quite right. Should we have scaled it before we shifted it? Oh, I know what's going on. The radius also has to be multiplied by the scale. Okay, so along with x plus equals shift x, y plus equals shift y, scale, excuse me, x times equals scale, y times equals scale. We need to revise the radius because the radius has to become bigger or smaller as well. Radius times equals scale. And I guess we could put some comments here as to what we're doing. Shift our XY coordinates so the drawing is closer to the middle of this screen. And then here we're going to add another comment as to what we just did. Scale our coordinates in radius to make our drawing larger. All right, that's looking good. Now I'm going to rearrange the order of my code. I don't want you to rearrange the order of your code, but I just want to see two things close together in the code so that it's easy to spot them. So I'm just going to move the crosshairs function way up to the top. Don't make this change, guys. All right, the reason I did that is so that I can have my code and then this stuff here with the coordinate calls real close to each other. Not quite perfect though, because I still can't get it all on screen at the same time, especially now that I've added so many comments. So anyways, this is what our new circle function looks like. We've added the shift x, the shift y, and the scale factor. And we changed x by shifting the x. We changed y by shifting the y. And then we scaled it by multiplying x, y, and the radius by the scale. If we didn't think 2 was large enough, we could do 3. Pick a number that you like. It sizes it appropriately on your screen. 3 is pretty good. Maybe 6. All right, I'm happy with 6. That's a nice big bear. All right, so if your code looks like this, as we've got here, our circle function, there, and you have your circles set up like that, then you will be drawing what mine is currently drawing. Kind of a Mickey Mouse head. Not really, but close. Okay, so let's draw more of the bear.
Okay, yeah.
So I need to find the original bear drawing. There he is. And just kind of make note of the coordinates that I want and the colors that I want. And you could do this on your own, but I'm going to do a few of the circles. Yes, sir.
How do we get the dark brown color?
Good question. Good question. Do I have any hints? If not,
I typed dark brown.
brown doesn't look too good, does it?
As well, but brown is more like a maroon.
Yeah, so let's see if we can find a list of colors. Okay, called TK
It's more brick.
Colors Python.
I don't mind that brick color.
That looks a lot better. All right, I'm going to post a link on our front page with a link to a web page that shows all the colors.
Looks more like a toy teddy bear with that brick color.
Yeah. All right, so if you go to our front page, you'll see turtle color chart. And you can pick a good brown, like maybe orange 4 or salmon 4. What is this one? Saddle brown. Okay, so I'll try that. Instead of tan, I'm going to draw one of my circles saddle brown. I think that'll work. I think saddle brown's going to work for me. You can pick whatever colors you want. So if I'm going to make a list of the circles, he's got some inner ears. It looks like this one is at position 22, 51 with a radius of, what did y'all decide the radius was of the inner ear?
8.
All right. And I'm going to make that saddle brown. I'm just making notes for myself. And the other ear, what was the origin of the other ear? About
It was 22,
54, right? 51,
no,
8, saddle brown. I'm talking about the inner ear now. Is that about where y'all put it?
Put it at 74, 51, 8.
Oh, you're right. It's not 54. Where did I get that? It's 74. It's 74. Okay. I'm going to go and modify my code to have those guys. And I want to do the nose too. The nose looks like it's at coordinate 48, comma 27. What did y'all do for the nose?
I haven't gotten there yet.
Alrighty, so I'm going to say 48, comma 27.
How are you seeing the number on the brown?
Well, like if I'm looking this one up, I'm just following it down here to see where its x coordinate is, and it's kind of lined up like that.
Oh, no, that's not right. You just using the word saddle brown.
Right, right. I picked a color from our color chart. If you go to the front page of our class and you follow the link there, it'll take you to this, and you can pick out whatever colors you want. Sienna 4 would also look awfully good. That looks like it also has a radius of about 8. Okay, so now I'm going to actually go and add those circles to my code. Now, I think I would be well suited to actually put some comments here as to what each one is. This big one is the head, so it's going to kind of need to come before all the ears. This is the outer left ear. This is the inner left ear. And so now when I start, no, that's the outer right ear.
How do you know?
Just because I remembered that 24 meant that it was on the left and 76 meant that it was on the right. So now I'm going to add 2 more for the inner ears. So circle 22, comma 51, comma 8. Comma quote saddle brown or Sienna 4 or whatever color you want to make his inner ears. And that's the inner left ear. And then circle 74.51, comma 8, comma quote, same color. And now finally for his nose. But I better put the nose after his head rather than before it, or else the head will obscure the nose. So circle 48, comma 27, comma 8, comma quote, saddle brown, end quote. That's the nose. All right, I think he's well on his way. I have a lot more circles to do, but I'm going to leave that as an exercise for you. Put his eyes in and the blue of his eyes and his little mouth, and you'll be done with the bear. The homework is to take the same code and delete all the circles for the bear and add circles to draw a turtle instead. The more often you run it, the more tired you get of watching it. So tired you are. So I'm going to do t.speed subscript, or excuse me, t.speed parentheses 0 in parentheses, and that'll speed them up. When you're happy with your bear, upload that into the Dropbox for you. Then go and look at the Dropbox for homework 16. So we use the code in lecture L to draw the following picture, but homework B, we want to draw this turtle. Not so easy if it's not on a graph, right? But here's a graph. So we could print this out, you know, and put numbers on it, or however you want to do it. However you want to draw it. I didn't put any numbers on this chart, so you could print that page out and fill in your own X and Y coordinates to get it going. So whatever page that was, if you don't have a printer, that would be a bit of a problem, but I bet you can figure it out. I bet you can figure out what you're going to do in order to be able to get this going. And so as a reminder for the other homework assignment, the last homework assignment called linear search, the code for it could be found in lecture T. A linear search is a for loop that iterates through your list like this. And so we could change the value from one value to another. So if we have something that looks like this, you could just stick this onto the bottom of your turtle code or at the top or whatever, but like if we have a list of values like this, and we want to find, I don't want that double number here, there. We want to find 555 and change it to something else. So we want to seek for 555 and we want to replace it with another number, although we would really be asking the user, right? We're going to replace 555 with -1 for whatever purposes. Then we would write a loop that steps through it, an index-based loop. For I in range, subscript L, or excuse me, len subscript L in subscript colon, if L subscript I equals seek, if it's equal to what we're looking for, then L subscript I equals replace. We replace it with a value that we want. And then let's print out our list afterwards with a for loop. For value in L colon print value, like that. So that's real close to being the solution for the homework. The other homework, the one prior to this one. Homework 15, I believe. Except you're going to ask for the values. Okay, so we wanted to change. Heck, this is already. That was another example of it. But there, after we did it, we had 1, 2, 3, 2, 2, 3, -1, 6, 6, 7. So that's just another example of the same code. From there to there. Another example of using linear search to do search and replace. Like that. All right, so that's the end of the assignment. Get your bear happy and upload that into the lecture Dropbox. And then, if you want to, print out the instructions before you go, because you can use a printer here so that you can put numbers on your piece on your graph paper. However you're going to do it. You have a printer at home, that's fine. I'll bring it back just a second. I just want page 3.